I'm dedicating this one to Ethan Hunt in Mission Impossible. How on earth am I going to do that? Well, think about the first movie. There's this scene in the movie where they go to get this little oscillus disc, and it's a famous line. Ethan Hunt's lying there suspended in midair with this cable, and then he's sweating, right? This bead of sweat's coming off his glasses that he's wearing, and he catches it in his hand. So those are like the environmental controls, and they talk about that in the train, that room temperature cannot be decreased by more than a single degree, then there's the moisture and all this stuff, etc., etc. It's the temperature that I'm interested in here. So if we were to represent that using inequality, we would have T for temperature minus 72 for 72 degrees Fahrenheit as room temperature cannot be exceeded by a single degree. So we're going to make that less than or equal to 1. So if we solve that for T, we would say that T would be less than or equal to 73, right? In other words, temperature can be below 73 degrees, it can be at 73 degrees, and we'd be fine. The minute it gets above 73 degrees, then you got problems. And they talk about that a little bit on the train as they're schematically planning out how they're going to do this heist of the oscillus disc. Well, suppose we got a little creative here. I'm going to dedicate this problem to the Batman movie with Mr. Freeze, right? The Arnold Schwarzenegger character where he plays Mr. Freeze, that one. Suppose that Tom Cruise's character, Ethan Hunt, gets a little creative and get Mr. Freeze, okay, moisture controls notwithstanding, to go in there and grab the oscillus disc. I mean, he goes in there, he drops that room temperature way down to like negative 20, which is below 73 degrees, right? And they can make off with the oscillus disc. Suppose you're the environmental controller in charge of the security, or that portion of the security systems in that room, and you wanted to account for dropping room temperature by a substantial amount. Enter in absolute values. You slap absolute value bars on this thing, that'll account for anything to go exceeding a single degree as well as going more than 1 degree below what you're after here. Allow me to explain a little more here. We talked about the and versus or before, right? And was what's in common. Which is also the intersection. And in this case, we're seeing that it's a less than or equal to. It's also a less than. Compare that to the or. Remember we talked about that. That's everything. It's on the number line, it's in the answer. And it's a union. And that would be in cases where you have greater than or equal to signs. Okay? So those are going to be your two situations there. So this guy is an and. And by the way, a good way to figure out whether it's an and versus an or, try to remember back to when you were in first grade and you looked above the chalkboard or dry erase board and you had the alphabet up there, right? What was over here? The A. This is pointing towards the A, and starts with A. What letter was over towards that end? Not quite at the end, but it was the O, right? These guys are pointing towards the O, or starts with O. So that's why I always remember, you look at this inequality, isolate for the absolute value first, then look at this inequality to determine whether you've got an and versus an or. Okay, that's going to be an issue as we go to solve this thing. So if it's an and, we can actually do this little maneuver. We could say -1 is less than or equal to t minus 72, which is less than or equal to 1. You can do that with an and situation. I've seen people try to sandwich what's in the absolute value inequality with an or. It doesn't work so well. Okay, so hold that with the ands only. Okay, we'll go ahead and solve this thing. We'll add a 72 to 3 locations here. We'll have 71, so less than or equal to t, less than or equal to 73. Interval notation, there you go. So it's the values between negative 71 and 73. So, you know, you got Mr. Freeze that comes in there and he tries to grab that oscillus disc. The room temperature drops more than a single degree, so it gets below 71 degrees. So all the bars come down, and the security guards come in, they cuff up Mr. Freeze, and they haul him off to jail, or grab Ethan Hunt while they're after at it. Works out pretty well. For those that couldn't stand the governor when he was the governor of California, this will take care of that. Because he'll be in prison, right? I know, it's a stretch. But that hopefully will give you an idea about how to do a compound inequality as an absolute value inequality with an and.